90% of developers who claim to know how ChatGPT works fail the follow-up question. The interviewer leans in and asks, "Okay, but what actually happens after pre-training?" And the candidate goes quiet. Don't be that candidate. In the next 10 minutes, you will know exactly what they don't, and you'll be able to explain the full pipeline cold in any interview room. Let's start at the foundation. GPT-4 was pre-trained on an estimated 10 to 15 trillion tokens. A token is roughly 3/4 of a word, so we're talking about more text than any human could read in thousands of lifetimes. The sources are things you'd recognize. Common Crawl, which is a massive scrape of the public web, GitHub repositories, Wikipedia, and digitized books. But here's what most people miss. Raw size is not the secret. Quality filtering is. OpenAI, Google, Meta, they all run aggressive deduplication and toxicity filtering before a single token hits the model. The internet is mostly garbage. The training data can't be. So what is the model actually doing during pre-training? One thing, predicting the next token. Every single forward pass, the model looks at a sequence of tokens and tries to guess what comes next. The loss function is cross entropy over the vocabulary. Basically, how wrong was your guess across every word billions of times per day for weeks of GPU time. That's it. There's no reward for being helpful, no penalty for being harmful. The model is just a very large, very expensive autocomplete engine at this stage. And that is exactly the problem. Meta released Llama 1 in early 2023. The base model, the raw pre-trained version, had to be wrapped in safety filters before any public release, because without them, it would happily complete prompts that no company wants associated with their product. The base model mimics the internet, and the internet contains everything: helpful tutorials, brilliant research, and genuinely dangerous content, all sitting in the same training corpus. A base model has no concept of being a helpful assistant. It has no concept of you at all. It just completes text. This is the gap interviewers are probing when they ask that follow-up question. Most candidates stop at "it predicts the next token" and walk right off the cliff. The real answer starts where pre-training ends. Stage 2 is supervised fine-tuning, or SFT. OpenAI described this in their Instruct GPT paper in 2022. That paper is your citation in any interview. Remember it. Here's what they did. Human labelers, actual people, wrote somewhere between 10,000 and 100,000 high-quality prompt and response pairs. Things like prompt is "explain quantum entanglement to a 10-year-old." Response is a clear, accurate, age-appropriate answer. The base model is then fine-tuned on these pairs using the same cross-entropy loss as pre-training, but on this tiny curated dataset instead of the whole internet. The result is a model that starts behaving like an assistant. It follows instructions, it sounds helpful, but it still drifts on edge cases. Ask it something unusual and it can still go off the rails. SFT is necessary but not sufficient. So how do you teach a model what good actually means across every possible prompt? You can't write labeled examples for every situation. There are too many. This is where the reward model comes in. Stage 3. Labelers take the same prompt and they look at multiple outputs generated by the SFT model. Let's call them A, B, and C. They rank them. A is better than B, B is better than C. A separate neural network, not the main LLM, a different, typically smaller model, is trained on these rankings to predict a human preference score for any given output. This is the reward model. Its only job is to score responses the way a human labeler would. Now here is one of the most common mistakes candidates make in interviews, and interviewers catch it every single time. They confuse the reward model with the main language model. They are not the same thing. The reward model is a classifier head on top of a transformer. It takes a prompt response pair and outputs a number. The main LLM takes a prompt and generates text. Two different models, two different jobs. Keep them separate in your head and in your answer. Stage 4 is where everything comes together. RLHF, reinforcement learning from human feedback, using an algorithm called PPO, proximal policy optimization. Think of the SFT model as your policy. PPO updates the weights of that policy to maximize the scores coming from the reward model. More reward signal means more updates in that direction. The model learns to generate outputs that score highly with the reward model, which was trained to match human preference. That's the chain. But there's a catch, and this is the most failed question in this entire topic. What stops the model from just gaming the reward model? What stops it from learning some weird output pattern that technically scores high but is completely useless? The answer is KL divergence penalty. During PPO training, there is a penalty applied whenever the updated policy drifts too far from the original SFT model. KL divergence measures how different two probability distributions are. In this case, the current policy versus the SFT baseline. Drift too far, get penalized. This is called preventing reward hacking, and it is the direct reason ChatGPT doesn't just output gibberish that happens to fool the reward model. And the numbers, because interviewers love specifics. Instruct GPT used approximately 40 human labelers, around 13,000 SFT prompts, around 33,000 reward comparison pairs. A relatively small team of humans shaped the behavior of a model used by hundreds of millions of people. That's the leverage point of RLHF. Let's lock this in with one clean mental model. Pretrain, predict the internet, 15 trillion tokens, cross entropy loss. SFT, mimic good human answers, small curated dataset, same loss. Reward model, learn human taste from rankings, separate classifier network. PPO, optimize the SFT policy to score high on the reward model. KL penalty keeps it honest. That's the full pipeline. 4 stages. Most candidates only know stage 1. Next lesson, we're going to get our hands dirty. We'll run a live RLHF pipeline on a tiny model using the TRL library and a Hugging Face reward model, so you can see every single stage in real code, not just slides. And before you go, this Saturday's EtherStack AI quiz is built around everything we covered this week. Pre-training objectives, how tokenization and data scale affect model quality, all 4 RLHF pipeline stages, and the interview traps around training versus fine-tuning versus prompting. If you watch this lesson, you already have an edge. Show up Saturday and prove it.